I need to prove algebraically that m plus 3 squared minus m minus 3 squared plus 3 is odd for all integer values of m. So first let me expand these brackets. Now you can do this with the grid method if you prefer, or you can just write it out as m plus 3 times m plus 3. The m times the m is m squared. Then we have the m times 3, which is 3m. Then we have the 3 times m, which is 3m. And then we have the 3 times 3, which is 9. So we get m squared plus 6m plus 9. Right, now I need to expand out the m minus 3 squared. So m minus 3 times m minus 3. So m times m is m squared. M times minus 3 is minus 3m. Minus 3 times m is minus 3m. Minus 3 times minus 3 is plus 9. Collect up those like terms and we get m squared minus 6m plus 9. But be really careful here. We need to take away all of that. So I need to take away all of that, so make sure you put it in brackets. I need to take away the m squared, I need to take away the negative 6m, and I need to take away the 9. So make sure you put all of that in brackets. Also, don't forget we've got the plus 3 on the end. Right, so I've got the m squared plus 6m plus 9. And like I say, I'm subtracting the m squared, and then I'm subtracting the minus 6m, which means actually I'm going to add 6m. The minus 6m will mean that I'm going to add 6m. And then I've got the minus 9. And then don't forget the plus 3. Right, m squared minus m squared, they've cancelled out. The 6m plus 6m is 12m. The 9 take away 9 is 0. And then don't forget that plus 3 on the end. So I've ended up with 12m plus 3. I now just need to explain why that is always odd. Well, I'm just going to rewrite that 12m as 2 times 6m. Just because writing it as 2 times a number proves that it is always even. So 2 times 6m is always even. Therefore, when I add the 3 to it, it will always be odd. Always odd. And we're done.